Carlo's Supina and Micah's drive left for dead Rust projects to revive. By making it dress up with an ECS, now it's perfectly looking alive.
Hi everyone, welcome to our talk on how to revive a dead Rust project. My name is Carlo, and today I'll be presenting together with Micah about our experiences working on a 2D shooter game made with the Amethyst game engine. I'm a welder who is currently pursuing AWS certification. I also run an education company called Micronote, where I make videos and articles about programming microcontrollers with MicroPython. In my free time, I enjoy tinkering with electronics, designing PCBs, and designing and printing 3D parts. I began my Rust journey by diving straight into embedded Rust, where I made a remote-controlled rover with sensors and an infrared camera. Then, wanting to get more conventional experience, I started working on a project called Keybrarian for managing schematics and footprints for KiCad. KiCad is an open-source electronics design automation suite. I also started working on a game called Space Shooter RS, which is a space shooter game made with the Amethyst game engine, with heavy inspiration from The Binding of Isaac.
Hey everyone, I'm Micah and I'm a software engineer at Mozilla. My background working on software is focused on front-end web development. Currently, I work on the Firefox web browser, working on the browser's UI. In my spare time, I like to write blog posts about my experiences in software development. My blog posts are a way to help myself practice delivering complex topics in a way that are simple and easy to follow. I got started with Rust over 2 years ago as an on and off hobby. Some of the things I've done since then is contribute to open source Rust projects and a few of my own toy projects. I recently started learning about game development using the Amethyst game engine. It was during this time I started learning about a common game development architecture called ECS and how it was used by Amethyst. And as a side note, we'll be explaining what ECS is later in this talk, so don't worry about knowing what it is right now. And so I decided to share my learnings at RustConf this year, where it helped solidify my own knowledge about the topic. In addition to this, I documented my journey learning game development with Rust by writing blog posts. And now I'll pass it off to Carlo, where he will explain the origin of Space Shooter RS.
In the summer of 2019, I was looking for a project to hone my Rust skills. I decided that I wanted to make a game, so I started looking for game engines that used Rust and found a website called arewegameyet.rs. This website had many resources for creating games with the Rust language. Here, I discovered a game engine called Amethyst, which used an unfamiliar architecture to me called ECS. I read through the Amethyst book and followed some tutorials, and eventually started working on my own game called Space Shooter RS. This game started as a simple space shooter game, where the player shoots enemies coming from the top of the screen. After a few months of consistent work, Space Shooter RS was chosen to be an official showcase game for the Amethyst engine. Space Shooter RS was initially a project for learning Rust, which meant it contained mistakes that a person new to Rust would make. It was also unorganized due to me being new to the ECS architecture of Amethyst. Specifically, the game contained large components with redundant data. This made the game difficult for me to continue contributing to, because if I had a couple hours to work on a feature, I would first need to reorient myself with the convoluted project before working on anything new. For this same reason, it was also difficult for others to contribute to. I was very aware that refactoring was needed, but I wasn't sure where to start or if it was even worth it. Because of these flaws, Space Shooter RS's progress slowed to a halt around the beginning of 2020, until 2 months ago, when I watched Micah's RustConf talk about her experiences with Amethyst. This talk inspired me to try working on my game again, but I ended up encountering the same problems. This is when I considered inviting Micah to collaborate on Space Shooter RS. She clearly had a passion for game development. She also had knowledge of industry practices through her work at Mozilla, and we appeared to be at a similar experience level with Amethyst. I ended up reaching out after, determining if I had time to commit to the project, if I had a plan to catch her up with the project, and if I had a rough idea of what needed to be worked on first.
I was interested in collaborating with Carlo because I wanted to expand my knowledge about ECS and the Amethyst game engine by working on an existing game. At first, I wasn't sure if I'd be able to help out meaningfully since I too was still learning Rust and Amethyst. And I wasn't sure if I'd be able to make good suggestions on how we can make the existing codebase scalable using an ECS architecture due to my inexperience. But I realized doing this collaboration would help these concerns I was having. Carlo knew the code better than I did, and he could guide me through the problems the project was having. It was also clear there were areas of Amethyst Carlo had explored that I haven't, so I knew I would be learning new concepts as well. And another nice thing about this collaboration was that we were both coming into this knowing we could learn something from each other. And since it was just the two of us, there was freedom for us to make mistakes and to learn from them. But of course, as someone who was not at all familiar with the code, it was still hard to know where to begin with refactoring the codebase. In this section of our talk, we're going to provide some background for the Space Shooter game. A little knowledge about how the game works will provide some background into some of the refactoring decisions we made. And this will lead us into discussing how we approached refactoring the existing ECS code to make it easier to work with. And then finally, we will be explaining collaboration strategies we use to help plan and execute the refactors we discussed. And now I'm going to hand it off to Carlo, who will be giving a summary of Space Shooter.
Here's a little background on Space Shooter. In this game, you play as a spaceship defending an objective. The goal of the game is to survive levels by destroying enemies, collecting consumables, buying items, and defeating the final boss. The game is inspired by The Binding of Isaac, with the main points of inspiration being items that synergize with each other, randomly generated levels, and satisfying controls influenced by physics. Currently, the game has 3 enemy types. Each enemy type has a distinct behavior to provide a unique challenge to the player. There are also 13 unique items. Items are purchased by the player, and when acquired, change the rules of the game to benefit the player. This could range from changing the speed of the player, to changing the damage the player does to enemies, or even changing the prices of items in the store. The game has 4 different consumable drops. Consumables are dropped by enemies when destroyed. So far there are drops that provide the player health, and drops for giving the player money, which in this game is represented by bright green space rocks. The money is used to purchase items from the store. Items are listed in the store for a price. When purchased by the player, the item will drop from the top of the screen where the player can collect it. There are also some animations, 3D backgrounds, and a work-in-progress boss in the game. I will now hand it off to Micah, where she will give an overview of the entity component system architecture that Amethyst uses.
Throughout this talk, we've been throwing around the term ECS, and it's important that we address what it is before moving forward. ECS stands for Entity Component System. It's a common pattern used in game development that makes it easy to compose objects in a game because components can be arbitrarily added to entities. This also makes development much more data-driven, since entities are defined by the components that are attached to them. So in summary, an entity, often represented with a single ID, can be composed of a number of components, and a component acts like a container for data that can describe an aspect of an object. And finally, a system is a piece of logic that can operate on one or more entities in a game. I find it easier to understand what ECS is through a series of examples. This slide shows a screenshot of the game with 5 circled objects. These objects are some examples of entities that are present in Space Shooter. The entities circled in this image are sprite renders for the strafer enemy, spaceship, steel barrel item, drone enemy, and enemy projectile. But as I mentioned before, entities are represented with unique IDs, which is why the entities circled in this image have labels numbering them 1 through 5. Attaching names to them, such as spaceship or enemy, are labels that make it easier to describe the entity's purpose to someone else. Next, I'll explain the role components play in providing entities characteristics that are required for them to function in a game. Entities have a number of components attached to them. These components define pieces of data that help describe some behaviors we expect an entity to have. And it helps to think of these associations as collections of data grouped together under one ID. In these diagrams, I have grouped together different components with the entity ID they are associated with. Entity 1 has the components sprite render, attack, health, and movement attached to it. And Entity 2 has similar components attached to it as well. If we needed to access a health component specifically for the player entity, then we need an expressive way to do this. One way is to have another component called player tag attached to the entity, so that we can differentiate a health component associated with the player entity from the others. Of course, having something like a health component attached to an entity doesn't do much on its own. We still need a way for the game to update the values of a health component when damage is dealt to the entity it's attached to, and this is where the system part of ECS comes in. But before we talk about the system part of ECS, we should address component storages, since this is how Amethyst efficiently accesses and updates on collections of them. Giving components their own storages allows for faster access to data needed when updating an entity's component state. This is especially important when a system may need to operate on hundreds of components at a time. Because of this, it's important that component storages are responsible for containing and managing components of one type. And for every component in a storage, they have an entity ID that they are associated with. Now that we have briefly explained component storages, we can quickly go over the system part of ECS. In this diagram, we have an example of an animation system implemented using the Amethyst game engine. The animation system needs a way to know what sprite image is drawn to the screen during each game cycle. This example shows that the animation system will need to read from a time resource. Resources in Amethyst are containers of data that are not associated with an entity. The other two storages it reads from are the animation and sprite render component storages. Using these resources, the animation system will write to an entity's sprite render component. In particular, a sprite render component contains a property whose value can be modified to tell Amethyst which sprite render should be drawn. The system uses this to change the value in relation to the time resource, which would result in an animation sequence. The animation component serves as data the entity should be using when determining what to modify the sprite render component with. Now that we have a better idea of ECS, we can identify some of the problems Space Shooter was experiencing that made it difficult to contribute to. One of the first refactoring tasks we have identified was that the Spaceship and Enemy component shared a lot of redundant data. These components made us take a step back and examine the basics of ECS. A few things we identified was that we wanted to avoid components that were bloated, had redundant data, and as a result were difficult to reuse. And we found these problems made some of the existing systems overly complex. The first 2 points, having components that were bloated and redundant data made it difficult to keep track of what data a component was responsible for. This caused some scenarios where it wasn't clear what a system was meant to do, and since these problems made them difficult to reuse, it also made these properties specific to the component they were associated with. And this meant that modifying something like the health stat of an entity would need to specifically access the component containing it rather than a generic health component. To understand how we could break down these components in a way that makes them reusable and concise, it helps to define a set of requirements. This means that we should define what the expected behavior of an entity should be. This would help conceptualize how the components of an entity work together. And we can do this by emphasizing pieces of functionality of an entity instead of as a whole. To illustrate this point, we can list some of the expected behaviors of the spaceship, enemy, and item entities as components. It might seem like a lot of components for only 3 entities, but if we keep in mind that every component is a small piece of data that represents a single piece of functionality for an entity, then it's easier to have a holistic view of the entity's behavior. If we look at the spaceship and enemy entities, we can see that they are expected to have a number of similar behaviors such as motion, animation, and health. These behaviors can be described as pieces of data in the form of their own generic components. Having components reusable between entities is what ECS strives to do. You might also notice that the spaceship, enemy, and item entities have a component with their same name. For the Space Shooter game, we made the decision that functionality that is specific to an entity should be contained by its own specific component. Now that we have some behaviors defined for the Spaceship and Enemy component, let's examine an older revision of the Spaceship and Enemy components. In particular, we'll take a look at the motion component as one of the required behaviors for these two. In these code snippets, Spaceship and Enemy components are defining data required for the motion behavior. But as we mentioned before, we wanted to avoid repeating this data and instead extracting them into their own generic motion component that can be attached to any other entity that requires motion. The images here highlight the properties that define motion behavior, and we can now move them into their own component. This motion component applies to entity motion within a 2-dimensional space. Motion in Space Shooter refers to an entity's velocity, acceleration, deceleration, and maximum speed values. We also simplified some of the properties to be represented as vectors, such as velocity, to store both its x and y values. And now I'll hand it off to Carlo, who will be explaining how our work on refactoring these components allows for designing more containable systems.
Before, when I was summarizing the game, I talked about items in Space Shooter. Items fuel the progression of the player in the game. They are purchased from the store, and they modify the rules of the game to advantage the player. As the player destroys enemies, their spaceship can collect currency, which allows them to destroy enemies more efficiently, which allows the player to collect more currency and more items, and so on. Since items are intended to affect every part of the game, how can we implement them so that the systems stay lean and focused, while at the same time allowing them to detect if an item is collected? For example, In the game, there's an item called Frequency Augmenter. When collected, this item sharply increases the rate of fire for the player. Collisions between items and players are detected in a system called Spaceship Item Collision System. All item components contain a hash map of data about what attributes the item affects. For the Frequency Augmenter item, this data represents an increase in the fire rate for the player. This data needs to find its way to a system called Spaceship System, which is a system for managing the spaceship attributes. So how do we get this data from the collision detection system into the spaceship system? The solution is through the use of an event channel. Event channels function as communication lines between systems. A good analogy for event channels is a radio broadcast. A system that needs to send data to other systems can initialize an event message with the data that needs to be sent. This message is then written to the event channel in the source system. This event channel can be thought of as a radio tower broadcasting a message. Other systems can then tune in to this channel by setting up an event reader to look for events of a certain type. Then the system can read the data from the event message and use it in the system. Going back to the frequency augmenter item, we can see that when the item is collected in the spaceship item collision system, the item data is used to initialize an item get event, and this event containing the data can be sent via an event channel to the spaceship system, where the attributes can be added to the spaceship that collected it. This method of sending item data between systems can be extended for items that affect any kind of system in the game. In this next section, we will go over how we collaborated together to implement the refactors we discussed previously. One of the most important parts of trying to revive the Space Shooter project was to establish a workflow that worked for the both of us. We needed a way to develop and capture the progress we wanted to see in the next few weeks. This meant that we would need to discuss and prioritize tasks we both agreed would get the project's code in a better place. We will be exploring 4 approaches we use to stay focused, which are collaborative coding practices, writing documentation together, communication, and weekly meetings. The first factor that has made our collaboration successful is our collaborative coding practices. When I started this project in 2019, I was using GitHub for little more than a place to safely store and distribute files. I had some experience using branches and pull requests, but I knew that I was not using the tools GitHub provides to the extent that I should be. I didn't really need to though, because there were very infrequent contributors to the project besides me alone. Part of the reason why I reached out to Micah to collaborate on the project was because I knew that she likely had a lot more experience using these tools through her work at Mozilla. After a week of working together, Micah built up enough trust for me to give her maintainer privileges so that she could more easily contribute to the project without having to go through me. This allowed her to manage issues, branches, pull requests, and other things related to the repository. I was in turn able to follow her lead and learn for myself how to use these collaborative tools. My last point about these tools is that even though we are communicating through direct communication lines, we still make sure to do public code reviews through GitHub, even if it is just a small change. This makes our decisions transparent, which is good for the growth of the project, and it established a formal process for reviewing code. Now I will hand it over to Micah to talk about the importance of documentation for our project.
Since Carlo and I were both learning new things as we refactored Space Shooter, we wanted to make sure that we worked on documentation as a way to record our progress and thought processes. This included tasks such as updating the README to be more of an entry point for learning about the Space Shooter project. Anyone who is interested in learning more, either about learning the game or contributing, would go to the project's MD book, where more thorough information can be found. MD Book is a tool written in Rust that is used to create modern online books from Markdown files. We decided to create a book for Space Shooter as the central location for documentation. Right now, our most important pieces of content would be helping anyone make new contributions to the project. This meant that we needed to create a basic contributing guide for those who were interested in contributing code. We also made sure we had a code of conduct in place to establish a safe environment where everyone can contribute and learn. While documentation about the project's architecture and code have been the main focus right now, Carlo has been actively working to provide contribution guidelines around adding new items to the game as well as artwork. The goal of this effort is to have more than one way to contribute to Space Shooter, which can be code, artwork, ideas for items, and even documentation. The online book for Space Shooter is still a work in progress, but anyone interested in previewing it can check it out at amethyst.github.io/space_shooter_rs. And now I'll hand it off to Carlo, who will be explaining the importance of establishing goals and ideas through weekly meetings.
Weekly meetings were critical to our progress so far. In these meetings, we establish short-term goals, which an example would be refactoring a bloated component into multiple smaller and more general components. Long-term goals, an example would be adding a boss to the game and what kind of components, entities, and systems it would require. And the last type of goal are these larger project goals that relate specifically to Space Shooter RS as a project. This is what kind of documentation do we want to have, and do we even plan on selling a version of this game at one point? These weekly meetings were also important for sharing ideas. Our main guiding principle for sharing ideas is that while some ideas are certainly bad, all ideas are worth sharing. This is important for us because we have to not be afraid of sharing ideas around each other to make sure that we are on the same page with the project. Some examples of things we might share are character abilities, item ideas, bosses, and the structure of the game. Now, Micah will discuss our methods for effectively communicating when working on the project.
Having a way to track discussions around some refactoring decisions was one of the best ways to capture our thought processes. We did this by having these discussions on GitHub issues and code reviews. If we had any questions or ideas about an issue we were working on, we would post them to the issue they were relevant to. Ideally, these discussions would involve any pre-implementation work such as clarifying the problem we're trying to solve before writing any code. Then, once a pull request has been submitted as a potential fix for that issue, we could move the implementation discussions to there. While these discussions can be done privately, information that is easily available would allow us to revisit the reasoning for why we decided to make certain implementation decisions. This can make it easier for when documentation is created to address this section of the code, or if a new architecture problem arises as a result of fixing that one issue. At the end of the day, making these discussions public on GitHub will help create an environment that encourages open discussion and questions with others. Sometimes discussions around implementation details can be less relevant when addressing an issue. This is when we discuss project ideas through direct messaging. It can be difficult to find a balance between deciding which are relevant to the task at hand and what ends up being unnecessary information. In general, project ideas that are not ready for the public are kept in direct messages. This refers to features that are not relevant to our current goal, such as future project ideas, and also any implementation ideas that are off topic. And now, I'll hand it off to Carlo, who will explain how creating informal documentation helped with communicating the state of the Space Shooter project to help onboard me onto the project.
I made 2 informal documents for when Micah joined the project. They were called Current State and Ideal State. The Current State document described the game as it currently was, and the Ideal State document described the game as I thought it should be after a refactor. The intent of these documents was for Micah to use them as a reference as she was getting familiar with the game, while at the same time explaining what my current intentions for the game were. As Micah became more comfortable working on the project, we were able to start using the Ideal State document to have in-depth discussions about what the ideal state of the game should look like. Over time, as we collaborated, this document slowly started to turn into a more informal ideas document, where we throw ideas out for discussion as we think of them. A lot of these informal ideas came from inspiration we drew from other games. After a few weeks of consistent collaboration on this project, I started working on a few more formal documents to put the longer-term ideas in my head onto paper. The first document of this type I created was a large flowchart explaining my ideas for what progression through the game could look like. This included the progression of levels, unlocking characters, where bosses would be, and how theming would change between levels. The next, more formal documents I created were the MVPs for the project. I say MVPs because I wrote 2 based on the 2 different scopes we have for the project. The first MVP was for Space Shooter as a showcase game. This includes how many items, characters, bosses, levels, and enemies you want in the game. The general rule for this MVP was that things should only be included in the showcase game to the point where they made sense for a game intended to show off the Amethyst engine. The second MVP was for Space Shooter as a fully released game. The only difference between this MVP and the showcase game MVP is that the general rule for this document is that it contains more content to make the game as fun as possible, rather than just to show off the engine. An example of this would be things relating to a story or even a secret ending. And now I'll hand it over to Micah to conclude our talk.
So in summary, the main takeaways on the collaboration approaches we used were that engaging regularly in open discussion is beneficial to capturing project process. Documentation is important for solidifying knowledge about project architecture decisions, and sharing ideas regularly keeps everyone on the same page. and this is what we found to be the most helpful for reviving a dead Rust project. If you're interested in learning Rust or just want to contribute to an open source game, then we'd be happy to help. Working on Space Shooter is a project that aims to be a fun and informative learning experience. Whether it's with code, art, and/or documentation, feel free to reach out, and we'd be excited to meet you. And thank you for attending our talk. We are now open to taking any questions.
Great talk.
Glad you liked it.
So first question is, why is item and spaceship collision a separate system from spaceship and enemy collision?
So we organized our systems to listen for specific event types. So like in this example, spaceship to enemy and spaceship to items were their own event types. And because of that, we decided to make the decision to create separate systems for them so it was easier to maintain the logic that was specific to those particular event types. But yeah.
Gotcha. Do you feel there's a difference between starting a game design with ECS and moving one from something else to ECS?
Yeah, I can take this one. Yes, so I've tried a few smaller games. I've done like a game jam in the past, and yeah, ECS was very unique to me because of the way it organizes the data. It's completely different. So I think the most developed one I've done in the past was something with Pygame, and I was sort of using the object-oriented tools there to best represent the data in that way, and it's very easy to get organized, and ECS is very good at constraining the data and systems into being organized, which is really nice. But as you can see, we need a refactor anyway, so you can still mess it up.
Of course, always. So it seems like ECS is a popular solution for games, but are there any situations where you would not use it?
I can't think of any, but I don't think we're still learning ECS, and I can't think of a situation where I wouldn't, but I don't think I know enough to speak fully to that.
Also, it seems that the Amethyst game engine in recent versions, I'm not quite sure if it's released or not yet, but it seems they're moving on to a new ECS system. Can you comment on that or know anything about that?
I know that, yeah, they're switching from a library called Specs to Legion, and I don't think I'm qualified to talk about it, but yeah, if you are interested in learning about that, you should join the Amethyst Discord, because that's where we learn a lot about it. So yeah, it's not something that it's something that we'll need to probably do some refactoring to adjust for that in the future. But yeah, join the Amethyst Discord, I think, to learn more about that.
Another talk. And another user asks whether you've had a look at the Bevy engine, which also is quite recent, and whether you can comment on it from the user perspective of an Amethyst user.
I can't comment on it, but because I haven't tried it yet, but it does look interesting. I know it uses like the same design philosophy, and I know that Amethyst, there was a post that was made that Amethyst is working with Bevy, and so yeah, I think it's a great engine that people should try too.
Great.
We're not in competition.
Alrighty then. I think we're out of questions.
Yeah.
So just 1 second, see if anyone came in. Oh no, we're good. Micah, Carlo, thank you so much.
Yeah, great to be here.
And until next time.
Yep, see ya.